wherein which the actual experiment that is being done by the staffs have been recorded, and a short tutorial less than 2 minutes is been done, maybe in some cases 3 minutes. So here it explains how the water flows through the V notch and how the hook gauge works. How do you measure the head? How do you use an collecting tank to calibrate the V notch and other things? So they get the feel. The next level is a 360-degree video, wherein which not been incorporated as of now into this virtual tour, but they will be able to access the setup and 360-degree, and you can see one staff who is operating and another staff operating the collected stopwatch in the collecting tank, and similarly so forth. So this will help. So this is a video. So this will help the students to perform this experiment. So basically this is a video tutorial that's made by InVideo.
Now adjust the hook gauge to obtain a head of water. Open the
complete small video tutorial.
Adjust the knob of hook gauge to change the water level. The difference between final water level and the initial water level gives the head of water.
So that was how we were able to showcase the students with all those things. So you can see over here, maybe a simulation, there's a Lopata and a small tutorial on experimental video. So now the question comes, what is Lopata basically? So now to showcase what is Lopata, so let me showcase the small YouTube video which shows you what does that mean and how that why did we come up during the COVID time. So hope my screen is visible and once.
Nobody has a patience to sit around and read. In this instant age, nobody has a patience to sit around and read or learn quietly, taking in all the information. Lopata, developed by Center for System Design, NITK Surathkal, serves the same. Lopata in Sanskrit refers to teachings in concise. It is a very short and apt video tutorial guide to the virtual lab experiments that can be performed. In the wake of these lockdown days, lethargy would have kicked in among students to continue their learning. But Lopata is a very befitting tool for academic activities, since it is a very small and easy to grasp video tutorial explaining the gist of the virtual experiment. The user will get hooked and proceed to perform the experimentation. Like other common schemes, Swayam Prabha, e-Pathshala, etc., Lopata is an aiding tool to the solve the virtual labs, which handholds and guides students through the virtual experimentation. When a user watches a Lopata, the user can access the links in the description, which will navigate the user to a virtual lab website. For example, Fluid Mechanics Lab. The user can go through the entire list of experiments and choose to perform any experiment any number of times at his pace, place, and period, just by making use of laptops or mobile phones or desktop computer. The number of people accessing virtual labs has significantly increased, and we have over 4.5 lakh user hits for Fluid Mechanics Lab alone in the year 2019. Lopata, improving learning experience of the student community throughout the nation.
So that was our main purpose of doing this concise video, because nowadays most of these classes goes online and they have to sit tight in this mobile and other devices. So how we can make this lab available, at their pace, and they operate at their place and at their period. So this is a thing that we try to do, and the most important points of labs, that simulation labs that we have developed, the team from NITK, it is independent on the operating system. It is you can use your mobiles, you can use your tablets, Android, or an Apple product, or a Windows device, or an maybe a Linux operating system based PC. It is independent. So in that reason, that has made independent, and students can use with the system that is available. So with this, uh, yeah, with this, I would like to open the floor for any clarifications that they have, so that we can based on it. Maybe suppose it is similarly there for mechanical, and in the civil engineering we have the strength of materials labs also, as well as it is common for mechanical students. So you can just browse over here. This is the lab that is there for the fluid mechanics, and similarly it is there even for the SOM or the mechanics of solids. Yes. So I'll just click on here, and maybe go on to any one of the labs on. Let me show for my courses. Yeah, 216. So you can do experience something called as experience SOM lab. So when you are experiencing SOM lab, you will be able to get this 360-degree of view of the front of materials lab, wherein we students usually get in and then try to operate. And so this is the thing, and from there they'll be able to go on to any one of the setups. Of course, we are updating one by one some of the data sets, but here is a UTM thing. From here, you will be able to go to the simulations, or else what you can do is you can go to the Center for System Design channel, and from that channel we have a playlist that is been done, and that playlist will help you to go to access any lab. Maybe this is an Lopata for fluid machinery lab. You have similarly the mechanics of machines. All these have been added as a playlist which can be used and showcased. So now this was a simple example of an strength of materials lab, and spoken tutorials, which are very short tutorials, less than 2 minutes. Yeah. And showcases how a machine can be done, how an experiment can be done. And if you see, this is also linked similarly with an actual experimental setup. So suppose if you go back and see the actual experimental video, Center of Materials Lab. From there you can select a Charpy test from the scrolling page.
Rockwell hardness test. This is the experimental set.
So from here there's a Charpy tutorial. So which showcases how a sample is kept, and how that experiment is done. So basically the entire simulation is 1:1 replication of this actual setup, and they will be able to perform it. Now what we have done is we have added a few data sets, maybe around 10 data sets. So every time you try to get a different values, and in some cases graphs are there, so the graphs can be plotted so that they'll get something of experiential learning. And so this usually what staffs or students use to operate it. This is how an sample is being placed. So this you can go through all these tutorials, and maybe our next batch will explain you how that is being done. So I'll open the floor for the or any clarifications that they want, so that they'll be able to, we can clarify it.
Sir, namaste.
Yeah, please.
Sir, initially you showed the video of the iris. I saw that iris. What is the website?
Yeah. Actually, it is exclusively only for our college group. I'll just share it back with you. Okay. 1 minute. This is basically this is basically developed in-house. for the faculty and students. So this is not accessible for the outside world because there is no login credentials for the outside world.
I see.
This is basically for a faculty, for him to take class, mark, upload the marks and other things. But regarding virtual labs, whatever, let us take one example. Let us say fluid mechanics itself once again, and I will go into this Moodle, wherein which whatever my students see is some same, almost the same visible to you. Only thing is you may not have this Moodle, but virtual tour link, basically if I click this in the new tab, this URL is accessible to you. I'll just click this. I will just share this in the chat box. I'll just share this in
Okay.
the chat box of the Google of this
Now it's
and
okay, fine.
yeah, so it is accessible to you. And similarly all others are VLab websites, which is also accessible to the common people. And you have YouTube tutorials, which is also accessible to the common. Only thing is the iris part is exclusively for the NITK group. It's only an integration part.
Okay, sir, fine. Thank you.
Okay, okay. Is there anything else? Similarly, there's mechanical. Maybe Professor Gangadhar would have showed one or two labs of vibrations, how we can explore and experience, change the mass, get the values. Here, what happens is, especially in destructive test, we don't do the option of don't give the option of changing the diameter of the sample, because we have kept it as standard, and they will be able to perform the test. Of course, what we have is we have data sets from the past lab experiments that we have inputted, so that the maybe if you take tensile test, the values keep changing. It comes in the range like 210 to 215, 200, in that range. So that people does not feel that it's basically a repetition of the same value. Instead of that, that many data sets have been populated. Anything else? Similarly, you can also explore the remote trigger facilities, especially for the lab. Peril or Shrestha?
Yes, sir.
Yeah, was the RT lab showcased?
Yes, sir.
Yes, sir.
Okay, okay.
Yeah, what about engine labs and machine shop lab like that? How we can
Uh, Maybe the next
workshop
team will
foundry
upgrade.
and
See,
code?
yeah, those labs NITK has not developed, but the team will showcase the labs which have been developed by other institutes like other IITs. That will be showcased in the breakout sections.
Okay, sir. Thank you.
Okay.
Sir, can you
Yeah,
explain turbine? Anyone? Turbine?
our fluid mechanics turbine, you are saying that is
Sir.
fluid
Turbine,
mechanical lab.
turbine.
Oh,
Fluid
okay,
mechanics.
okay.
Please, sir.
So maybe I will
Francis, sir, Kaplan, or
anything basically.
anyone. Pelton wheel. Anyone.
Yeah. So I'll just share this screen. I'll go to this simulation, and what you can also do is basically click on this channel. So I'll just showcase that and go into the fluid mechanics and check for playlist. And it is a fluid machinery or fluid mechanics. Any one lab it will be given. Fluid mechanics, fluid machinery. Yeah. So maybe assume that we are talking now on maybe we told an Kaplan turbine. So let me also showcase the same one. Constant head, Pelton, Francis, Kaplan, or anyone say Francis over here. Okay, and in along with that, I'll just showcase one more setup, wherein which the simulation tutorial is being showcased. So here we should find for the word Lagopata with for fluid mechanics. So it's a fluid machinery lab. So maybe if I click onto it, centrifugal or Francis or something like this. So I'll just show this. So of course, what tab shared may be different for different, but basically, if you see over here, it is showcasing how the simulation is done for a Francis turbine for a constant speed, and so Francis turbine at a constant speed. So this is a actual setup. So what you can also do is go on to the virtual tour over here, maybe that what we have showcased, and from there link on to see the Francis turbine. Francis turbine. So this is a Francis turbine setup. So from these individual tabs, you'll be able to only go on to one setup by one setup, so that there'll be no confusion for the students. And you can see how the setup is and how you get an how does a pump delivers to the turbine, Francis turbine. From there, how do you do the load test, and you can also see the still image out of it. Now, you can see a staff who is holding the tachometer and trying to find the RPM. So these are some of the still images, and maybe you can go to another 360 view and see how this setup looks in another angle, so that they'll be able to really feel how the setup is. Now, let us come to the same. What we were discussing was Francis turbine. So similarly, let me go on to the same fluid machinery list of experiments. In that it is Francis turbine. Yeah, and from there you can go to simulations. Yeah, so this is a page. So you have this constant head experiment for constant speed, different things, so that you can activate the pump. So this is the head that has been selected. Of course, you will get a true or false active, so you will be able to get, and you will be able to proceed further. Now you'll be able to operate the wall, and the gauge will change. And the same thing you have in terms of a spoken tutorial called Lagopata, and the same thing you have in the terms of an video tutorial. So now you can see over here, there's an equation which tells how the torque is been calculated. I'll just enter a random value, so that and two attempts you get to do it, and then you can keep that tachometer. This is a zoomed view which will help you, and it shows what is the RPM. And of course, when the water flows out, you will be having an notch which is used to measure the head, or the hook gauge. And from there, this equation that is being given, and you will be able to calculate the value. You can use this equation, calculate manually by using a calculator, and then get it. So you can actually answer. Suppose if it's wrong, it will directly tell you how it has been done. So now there are so many other interactive things. Along with that, you will be able to check what are the observations. From observations, how do you get the results. So I'm just randomly putting these values over here just to speed up, and you can see what is right, what is wrong, and you will be, and also there is an actual tutorial which explains you how the, so you have to repeat trial 1, trial 2, trial 3, which is used for plotting the performance chart. Maybe over here I'll just fast forward this actually tutorial, and if you see at the end, this is a graph that is required actually for the students to plot. I'll just share this tab.